I'm gonna be doing 3.6. So here they're asking which of the underlined ones are acids. Here you can tell by either looking at the thing itself or what it's reacting with. So for this one, it's easiest to just look at it itself. It's a hydroxide, so it's basic, it's not acidic. Here it's an ion. You can easily tell if it has a charge. It's an ion. Here you might think it's a hydroxide. Oh no, there's no way it's a hydroxide. Look, bases split up into this. For example, we'll use NaOH itself. It splits up into Na plus OH minus, yeah? That's what Na splits up into. So you think, oh, this one splits up into CH3CO plus an OH minus, yeah? It doesn't split up like that. It splits up into O minus and then H plus. So the H is the one being added. So that's how you can tell. You have to memorize it. It's called acetic acid or ethanoic acid, whichever one you want to call it. And also, another way is because you should know by now, since topic 8 or 6, or for the Haber process, ammonia is basic. Here you can tell acids usually start with H. That's how you can also tell this is an acid. This isn't an acid. This is like it's water that took a hydrogen. It's hydronium, I guess. So here you see, starts with an H. It's an acid. It reacted with the base. Here starts with an H and it reacted with the base. That's two ways you could tell. Here it's the exact same as this one. And again, ammonia, you should know by now, it's basic. Sorry. You only have to memorize 3 facts and they're all extremely easy. Anything equal to 7 is neutral. Anything with a pH of 7 is neutral. Anything with a pH less than 7 is acidic. Anything with a pH more than 7 is basic. Or alkaline, whichever one you want. They're both correct. It's both the same thing. So look here. This is less than 7. It's acidic. This is 7. It's basic. It's more than 7. It's acidic. It's basic, sorry. More than 7, it's basic. 7, neutral. Neutral, I got confused, my bad. So acidic, neutral, basic. So strong acid is an acid which completely dissociates in water. Like, for example, hydrochloric acid, HCl. It completely splits up. Yeah? There's no going back. See? There's no reverse arrow. It's just one arrow. It completely splits up. While a weak acid is a weak electrolyte. Like acetic acid, the one that we just saw. Or I'll do, I think nitric acid is weak. I might be wrong. But look, if it has a double arrow, it means it's weak. Acetic acid is definitely weak. So if it has a double arrow, it's weak. If it has a single arrow, it's strong. So here, a strong acid is an acid which completely dissociates in water, while a weak acid is a weak electrolyte. An electrolyte is what splits up in water and gives you ions. The pH of a solution is the measure of the concentration of hydrogen ions in the solution. pH stands for power of hydrogen. That's what you have to remember. At normal conditions, aqueous solutions, it's the exact same like the last question. This part C is like the last question. Less than 7 are acidic. More than 7 is basic. Equal to 7 is neutral. Here look, a strong acid completely dissociates in water, producing H plus and negative ions, and has a large dissociation constant like this one. So the dissociation constant is really similar to the equilibrium constant. Look, so you have, you guys remember how the equilibrium constant K works, yeah? Take the product over this. The biggest number you can possibly get is 1, yeah? But the higher the number, the stronger the acid is. Look, the reason this one has a large dissociation constant, it completely splits up. So I'll give you an example. Let's say this is before, okay? So before, and this one is after. So you have a bunch of HCl's, yeah? HCl, 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 like that, okay? When it dissociates, every single one of them dissociates into the H plus and the Cl minus, H plus, Cl minus, like that. H plus, Cl minus, every single one dissociates. So obviously, the product side is going to be way more than the reactant side, because every single one of the HCl molecules dissociates. Here's the opposite. A weak acid partially dissociates in water, producing H plus and has a small dissociation constant. So now let me show you what small dissociation constant. When this over this, the number is going to be small. The smaller, the weaker, the larger, the stronger, and it's the biggest number you could possibly get is 1. So this is what they mean by partially dissociate. So again, before and after. I'm gonna use because like this word's way too much. I'm gonna use it as A. Imagine it's A, yeah? This one, anion. I'm gonna write it. Anion. So HA, 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 okay? If it was strong, okay, I'm gonna write this one for strong, and weak, okay? So let me just fix the box, it's too small. Okay, look. So if it was strong, it would be like this: H plus, A minus, H plus, A minus. Every single one of them, yeah? There's not gonna be any left. H plus, A minus. For weak, barely any, only like maximum 1 will split up. See, H plus, A minus, and then the rest are just HA, HA, HA. See, only like, if it was this much, only one of them will split. You get it? So that's why it has a small dissociation constant, because there's not all of them dissociate. So there's still a lot of this one, but there's not a lot of this one. So that's why it's gonna be really small. An acid, this is Brownstead-Lowry. He said this. Arrhenius said acids. There's 2 of them, yeah? There's 2. These are conceptual, not operation. So you have Brownstead-Lowry, who said this. I might spell his name wrong, yeah? So Brownstead-Lowry, who said this. And then Arrhenius said that an acid... He said that an acid, like... I probably spelled their names wrong, but an acid is an H plus, releases H plus, and the base releases OH minus. Remember these, because they might ask you about. So what that means is an acid is a proton donor. Look, for example, HCl plus NaOH. You should know by now, it gives you salt and water. So NaCl plus H2O. What they mean by an acid is a proton donor, see how Cl is here by itself? Where'd it go? It released, where did the H go? It released the H into the solution. Yeah? It just threw away the H, it donated the H. It's a donor, it donated the H into the solution. And see how here there's 2 H's and there's 1 O? And same here, there's only 1 O and 1 H. So after releasing this one, the base picked it up. So the OH picked up the third H and it dissociated from this. That's what they mean by proton donor, proton acceptor. Gas X passed into water, pH of water changes from 7 to 10. Remember, anything more than 7 is basic. So that means it went from neutral to basic. Which one of these is basic? You should know by now, it's ammonia.